Water is essential to human, plant, and animal survival. As our second primal need, right after oxygen, water is one of the most precious resources on the planet. Groundwater is stored far below the Earth's surface, in soils and rocks that are able to hold the water in the openings and cracks, like a sponge. From huge cities to tiny villages, about 50% of the world's population depends on groundwater every day. Just in the United States, groundwater makes up almost 40% of the water used for irrigation, bathing, and drinking. In Mexico City, one of the world's most populated cities, there is no nearby surface water. That means that 95% of the population relies on groundwater for all their water needs. And then, all the way across the Atlantic in Denmark, a staggering 99% of the drinking water for the entire country comes solely from groundwater. So, what's the problem? Well, groundwater is the most abundant source of fresh water on Earth, it remains a hidden resource. We often know where to locate it, but what really keeps it hidden is the limited amount of data about its availability, current state, and use. In other words, we often have insufficient insight into the water below the ground. Let's look at an example. As our climate changes, droughts are happening more frequently. With a drought, there is less surface water, which leads communities to depend more and more on groundwater. But how can they know how to use it sustainably? Some communities may be polluting the groundwater reserves unknowingly through farming activities. A valuable resource could become seriously contaminated just because we can't see what effects our actions have below ground. This has consequences for everyone using the aquifer.
Good day everyone, we are the Group 3 and for today's video we're going to talk about groundwater and its services. But before we start, let's read first the objective of our lesson.
Hi everyone, my name is Emery Miliar and I will be the one to discuss the objectives and trivias of groundwater. First is the objectives of groundwater. Students will be able to identify the different types of groundwater. Students will be able to explain the importance of groundwater as a resource on the planet. Students will be able to enumerate the variables that influence the rate of groundwater flow. And lastly, students will be able to describe the saltwater penetration.
We all know that the Earth is full of water. 71% of the Earth is made up of water. The water we see in the surface of the Earth is surface water in the form of rivers, lakes, oceans, and seas. But the ground below our feet, there's even more water, is what we call the groundwater. What is a groundwater? A groundwater is a fresh water from rain or melting ice and snow that soaks into the soil and is stored in the tiny spaces or pores between rocks and particles of a soil. It accounts for nearly 95% of the nation's fresh water resources and stay underground for hundreds of thousands of years, help fill rivers, streams, lakes, ponds, and wetlands, and come to the surface. It was found in the two zones, the saturated and the unsaturated zone. When we say unsaturated zone, it is immediately below the land surface contains water and air in the open spaces or pores, while the saturated zone is a zone in which all the pores and rock fractures are filled with water, underlies the unsaturated zone. How does the ground store water? Groundwater is stored in the tiny open spaces between rock and sand, soil and gravel. How well loosely arranged rocks such as sand and gravel holds water depends on the size of the rock particles. Did you know where does the water we drink comes from? Groundwater can also come to the surface of a spring or be pumped from a well. Both of these are common ways we get groundwater to drink. About 50% of our municipal, domestic, and agricultural water supply is a groundwater. So how is a groundwater contaminated? Groundwater can become contaminated in many ways. First, if the surface water that recharges an aquifer is polluted, the groundwater will also become contaminated. Contaminated groundwater can then affect the quality of surface water at discharge areas. Second, groundwater can also become contaminated when liquid hazardous substances soak down through the soil into a groundwater. A combination of moving groundwater and a continuous source of contamination can therefore pollute very large volumes and areas of a groundwater. So we humans should be all responsible on the activities that we are doing. Like for example, when we are using fertilizer in a plant. Why is cleaning up groundwater is so hard? Cleaning up contaminated groundwater often takes longer than expected because groundwater systems are complicated and the contaminants are indivisible to the naked eye. This makes it more difficult to find contaminants and to design a treatment system that either destroys the contaminants in the ground or takes them to the surface for cleanup. Did you know that groundwater contamination is the reason for most of Superfund's long-term cleanup actions? Diagram illustrates groundwater treatment in action. To broaden our knowledge about a groundwater, there are 4 surfaces in these. These are the water table, aquifers and wells, springs, and geysers. I am now introduced to you, Ma'am Erica Malgapo, to discuss the first surface of a groundwater, which is what we call the water table.
Annyeong everyone, my name is Erica P. Malgapo, and so for now I am going to talk about the water table. So for us to be able to understand and to know what water table is, so you better listen. So first, what is the water table? So water table is the underground boundary between the soil surface and the area where groundwater saturates spaces between sediments and cracks in the rocks. So the water table is have 2 zone, which is the saturated zone and the unsaturated zone. So what is the saturated zone and the unsaturated zone? So first, let's start with the saturated zone. So when we talk about the saturated zone, it is the where water fills all spaces between the sediments. And also the water zone is bounded at the bottom by the impenetrable rock. So let's proceed with the unsaturated zone. So unsaturated zone is the soil surface above the water table, and where both oxygen and water fills the spaces between the sediments. So unsaturated zone is often called as aeration due to the presence of the oxygen in the soil. So as what we seen in the picture that I have put on the presentation, it seems that we can see how water table can be divided into two zones, which is the saturated one, or the saturated zone rather, and the unsaturated zone. So I hope you better understand what water table is and what does the unsaturated and saturated zone means. So that's all, and thank you.
Another source of groundwater is aquifers and well. So what is aquifers and well? Let's find out. When a water-bearing rock readily transmits water to a well and spring, it is called aquifer, while a well is a hole drilled into the ground to penetrate an aquifer. So in hydrology, aquifer it is a rock layer that contains water and release it in appreciable amount. It is the naturally filtered groundwater by forcing it to pass through the small pores and between sediments with help to remove substances from water. So this is the naturally filtration process, however, may not be enough to remove all the contaminants. While it is an structure or excavation created in the ground by digging. Like what I said a while ago, it is a hole drilled into the ground to access liquid resources. Usually, it is a water naman. And you know what? The oldest and the most common kind of well is a water well. So for our next slide, I will show you the examples of aquifers and well. So here's some example of aquifers and well. Actually, most of groundwater, including significant amount of our drinking water, comes from aquifers, and in order to access this water, a well must be created by drilling a hole that reaches the aquifers. So we have here the Mahiwagang Balon in Camiling Tarlac and a well water that we usually see in our house.
Liza Luis Tilagasca. So as we continue our discussion to you, so I will discuss to you the spring. So a spring is a water resource created where the side of a hill or the bottom of a valley or another excavation intersects a moving flow of groundwater at or below the local water table, where the subsurface contained is filled with water. A spring is formed as an aquifer fills to the point that the water overflows on the ground surface. They vary in size from occasional seeps that flood just during heavy rain to massive pools that drain hundreds of millions of gallons per day. So as you can see, this is an example of a spring. So a spring occur when water pressure causes a natural flow of groundwater on the Earth's surface. As rainwater enters or recharges the aquifer, pressure is placed on the water already present. This pressure moves water through the cracks and tunnels within the aquifer. And this water flows out naturally to the surface at places called springs. So next. So as you can see in the illustration, this is anatomy of the spring. So here, this is the aquifer system. So this is the ground water flow here, and if the groundwater flow and the gravity pushes the water upward, it can create a spring. If they have crack or tunnels that pushes the water up, that can create spring. So water that emerges from the ground at a spring can flow downhill and into a stream. If a spring's water cannot flow downhill, it can create pool and create a pond or lake instead. Spring water may be the only safe source of water in the desert. A spring can encourage wildlife to live in an otherwise uninhabitable field. So kapag daw yung spring can flow downhill, papunta sa stream, and kapag hindi daw siya pwedeng mag-flow sa downhill, it can create pool or lake or pond instead, or mag-i-stay lang siya sa isang place. So,
and these are some of the examples of springs here in the Philippines. So at first, we have here what we call Pangub Hot Spring that is located in Camiguin. The second one is the Hidden Valley Spring that is located in Laguna. And last is the Malupati Cold Spring that is located in Antique. In addition, do you know that spring is not just a place to go on, not just a place to swim on, and not just a place to relax on? Spring has an importance in our daily lives, as well as global importance, because spring provides fresh air and plays a vital role in the greater hydrologic cycle.
Hi, hello, good day everyone. I'm Julia Anita Querido from Bisad Wandi, and I'm here to explain with you what is geysers. So, as you can see in our PowerPoint presentation, a geyser is an unusual type of hot spring that explodes under pressure, shooting water and steam into the air. It is generally found in regions of young volcanic activity. Surface water percolates downward through the rocks below the Earth's surface of or to high temperature regions surrounding a magma reservoir, either active or recently solidified, but still it is a hot surface. So, geysers are developed by a tube-like hole in the surface of the Earth that extends deep into the crust. The tube is filled with a lot of water. Water slowly flows back into the tube after the explosion. The procedure starts all over again, and the eruption of some small geysers will take only a few minutes, and it can take days for the larger geysers. Some people ask if geysers are dangerous. So geysers are smaller and less dangerous than volcanoes, and they erupt or they explode occasionally. How do geysers work? So to understand how a geysers work, we must first understand the relationship between water and the steam. Steam is a gaseous form of water. Steam is produced when water is heated to its boiling point. When water converts into steam at surface conditions, it undergoes an expansion because steam occupies 1,000 times as much space as the original volume of water. The eruptions of a geysers is powered by a steam explosion when boiling hot water suddenly expands into the much more steam. To summarize what I said, a geysers erupt when superheated groundwater confined at depth, and it becomes hot enough to blast its way to the surface. So that's all, and Mom Jasmine Felipe will lead us through examples of geysers. Thank you for taking the time to listen.
Examples of geyser. Number 1. Valley of Geyser. Most amazing ancient ruins of the world, suited on the Kamacha Peninsula in the Russian Far East. The Valley of Geyser is the second largest geyser field in the world. The Valley Geyser was discovered in 1941 by located scientist Tatiana Ustinova. Since then, it became a popular tourist attraction in Kamchatka. The Valley of Geyser has suffered significantly from a landslide in 2007, which brought about half of all geysers. Nevertheless, the valley is still alive and attracts a lot of interest from scientists and tourists. Number 2. El Tacho. El Tacho is a famous geyser field suited with the Andes mountain of northern Chile at height of 4,300 meters, 13,780 feet. The climatic condition and high at altitude make the geysers field one of the most extreme environments on Earth. With over 80 active geysers, El Tacho is also the large hemisphere and the third largest field in the world. Despite the icy cold weather, many visitors take a dip in the hot spring. Number 3. Rotorua. Rotorua sits on the shores of Lake Rotorua of New Zealand. It is known as the thermal wonderland at New Zealand. There are numerous geysers and hot springs in and around the city. Many of these are in parks and reservoirs. Natural eruption of steam, hot water, and bad location. Nearby Waiotapu has many famous hot springs, noted from their colorful appearance, in addition to the Lady Knox Geyser.